Okay, so this is your science teacher, Mr. Zhong. So in this video, we're going to talk about the particle model. First of all, the word particle here means that very tiny substance called 粒子. Okay, while model is talking about 模型. So basically, a particle model is a way of thinking of this whole world. They are all made of these tiny particles. Okay. So first of all, I think from primary school you know that the states of matters. So matters here basically means substance. So everything has mass. They are the matters. What's up? Okay. While states is the way of how they present themselves. 形態. Okay. So all of you know there are three states of matters. They are solid, liquid, and gas. Solid, 固體, liquid, 液體, or gas, 氣體. Okay. So first of all, before going deeper, let's have a very quick guess game. Okay. So try to name all these solid. So A, what is that A? Okay, A is the glass. In fact it's glass rods. How about B? Pointing something that inside a glass bottle. Yes, they are the salts. Well, this one, rubber. This is something floating on the Coke. They are the ice. Well, this one is the coin. And what is this? They are the candle. So these are the example of solid. How about these liquid? So what are these? First of all, this is water. Second, this is petrol. So petrol is the fuel that used for this vehicle, the car. How about this one? Yes, this is used for cooking, oil. And this, probably it would be very difficult for you to buy right now because of the disease. So this is alcohol. Alcohol. Okay, 酒精. And this one, milk. And these, obviously, tea. So these are all liquid. Okay, so how about these? These are all gas. So what are all these gas? First of all, this is steam. It is the gas form of the water. The second one, okay, so these balloon, so they are hydrogen. Okay, well this one, this is the patient, obviously. So there is the device to provide the oxygen. Okay, oxygen is a gas. How about this one? Well, hey, town gas, obviously town gas. Well, this one, this is usually used for camping. Okay, so this is the camping gas. And the last one, this is air. So all of these are example of gas. So when we going to tell, okay, so all of these are solid. So can you think of any common features? What are the common features do they have? So first of all of them are solid, and all of them they have fixed shape as well as volume. Okay, they have fixed volume, they have fixed shape. You can't change them easily. How about liquid? So all of these are liquid. So unlike the solid, they do not have a fixed shape. So their shape, in fact, it depends on the container. depends on the container. So they do not have a fixed shape, and but still they have the fixed volume. How can we tell do they have the fixed volume? Very simple. Try to think about it. Can you, let's say, you have a syringe, 針管、針筒, okay? So try to put something into it. Let's say I put some sand. Let's say some sand, okay? And you found that it is very difficult for you to press on it, okay? The volume does not change. Of course, when you press it, you have to make sure that the sand does not leak out, okay? So that's why sand cannot be compressed. And because they have fixed volume. How about if we change another situation? Instead of sand, right now we put it water into it. Okay? So again, similarly, do not allow the water to leak out. If we compress it, you can find that, oh, water, although it can change the shape, but still water cannot be compressed as well. Okay, cannot be compressed as well because they also have fixed volume. Okay, so remember, liquid, they have fixed volume. Remember, they cannot be compressed. They can't be compressed. But still, they do not have fixed shape. Now, what happens if I change this into another thing? Instead of solid and liquid, what happens if I put gas into it? If I perform the same action, what will happen? So you may try in your home. So if we try to do this again, but right now we put nothing into it. Okay, so inside we just allow some air. And if we again we stuck it, okay, you found that if we try to press on it, okay, so we can somehow press a little bit, okay, we can change. These are all air. So we can change the volume of the air. We can compress air. And at the same time also air, also gas, does not have a fixed shape. Okay, okay. So right now, solid and liquid. What happens if we heat the solid? Okay, if we heat the solid eventually, what will happen? So these are the ice. Ice is a kind of solid. What happens if we heat it? Eventually it will melt and eventually turn into liquid. What happens if we try to heat up the liquid? So water is a kind of liquid. So the liquid eventually will boil and turn into gas. Okay, so liquid will turn into gas if we heat it. The other way around, what happens if we cool? There's some typo right here, so this should be liquid and this should be gas. Sorry about that. So what happens if we cool the liquid? So water is a kind of liquid. If we cool it, it will eventually become ice. How do we cool this? So eventually the liquid will freeze and turn into solid. So liquid. Okay, if it is water, it freezes and will turn into ice. Okay, how about gas? Okay, I wonder, have you ever seen this situation? If you put a very cold uh, cold water, let's say cold water, a bottle of cold water, eventually you could find some water droplet outside the surface. Okay, the reason, because in the air there is water vapor. So when the water vapor contact the cold surface, okay, it will condense and turn into liquid. Condense means yin, deep, okay? While freeze, similar, yin, gu, okay? So this slide, or these two slides, telling you that in fact solid, liquid, and gas, they are interchangeable. So depends on the temperature. So when solid turn into liquid, liquid is melting. While when liquid turn to gas, this is boiling. Okay. Well, the other way around, if we try to cool down the gas, okay, so gas will condense back to liquid, 凝結, and if we continue the process, it would become liquid after freezing. Okay, so this is the key so far we have covered. Okay, so first of all, there are three states. There are liquid, sorry, solid, liquid, and gas. Solid have fixed volume as well as shape. While liquid, they have a fixed volume, but they do not have a fixed shape. While gas, they do not have fixed shape nor fixed volume. Okay, so solid, as we've mentioned, can turn into liquid if we heat it. Solid will melt. Okay, so the liquid will boil and turn to gas if we heat it. So these two are the heating. What happened right now if we cool? If we cool the liquid will freeze and turn into solid. If we cool the gas will condense and turn into liquid. Okay, so please pay attention on these words. Make sure you know their spelling and their meaning as well. Okay. Okay, now let's enter the next part, particle model. So, as first mentioned, particle model is a way of thinking that consider all the matters. They are made of some tiny particle. So, for example, this is the block, a big solid. But if we will think that, oh, in fact, they are just formed by these red dots. Okay, these red particles. Okay, so this is the microscopic view. Microscopic view, which means that 微觀世界. Okay, so a particle model is a way of thinking that, oh, this our whole world. It's basically is made by these tiny particles. So somehow just like all these Legos. Okay, all these Legos. So right now we just know that the solid, in fact, they have these following properties. First of all, solid is very hot, and they have a fixed shape, and as well as their fixed volume. So if we try to explain these properties, okay, properties here means special behavior or characteristic of substance, đặc性, okay? So how can we explain these using the particle model? Okay, why it is hard? So first of all these particles in the solid, they are not allowed to move around. Okay, they have their fixed position. Their position is fixed and in a regular pattern. That's why they are not allowed to move, and that's why it is very hot. Okay, so why they have a fixed shape? Okay, if they have a fixed shape, which means that they are not allowed to move around. No, they cannot move. Okay, so the reason because they are hold tightly to their neighbor particles. Okay, they are not allowed to move. And why they have fixed volume? Why they cannot be compressed? So why we cannot compress them? The reason very simple, because the particle in the solid, they are very close to each other. They're very, very close to each other. The spacing is almost zero. No space between particles. That's why they are not allowed to compress. Okay? So this is the way of having using the particle model to explain the features of solid. Now, how about liquid? So we know that a liquid is soft. Although I think that this is not a very good way. So, well, basically it means that they do not have a fixed shape. Okay, don't have fixed shape. Do not has a fixed shape. Fixed shape. Yes, they don't have a fixed shape. Okay. So, and also they have take the shape of the container and they have fixed the volume. So the reason very simple why they are somehow called soft and also why they do not have a fixed shape. The reason very simple because the particle in the liquid they are allowed to move. So this is the microscopic view. Okay. So in fact they are moving around. They're moving around. But this moving, we call it they are sliding over each other. Okay, they are not flying around, jumping around. No, they just move. They move closely near each other. Still, they also have a fixed volume because they are also close to each other. Although they are able to move, but they only able to move around, sliding over each other. Okay, the spacing is still little. Okay, almost zero. Little spacing between the particles. Okay, the next one, gas. We know that gas, they do not have fixed shape and at the same time they do not have the fixed volume. Okay, so the reason very simple, they do not have fixed shape because the gas particle, they are able to move around in any direction. Okay, which means that uh, they can move in any different direction. Okay, so this is not equal to sliding over each other. Okay, not equal to this one. I would say moving around in any direction is more freely comparing to sliding over each other. Okay, and they do not have fixed volume, which means that they can be compressed. Can be compressed. Why? The reason very simple, because the particle they're far apart from each other. Okay, so if we use the syringe example again, so let's say 1, 2, 3, 1, 2, 3. It is still okay if I reduce the volume. Okay, so I can reduce this amount of volume. Okay, this amount of volume. It's still fine for them because there's a lot of spacing. A lot of spacing between particles. Between particles. That's why they can be compressed. So this is the summary. So how the particle arrange in gas, liquid, and solid. So first of all, pattern. Liquid, they are arranged in a very regular pattern. This, they are very regular. Okay, they have a fixed shape, they are very hot. Okay. However, for liquid and gas, they are not in a regular pattern. Not in regular pattern. That's why they do not have fixed shape. No fixed shape. Okay, no fixed shape. And at the same time, they are distant between particles. So consider the distance, okay, between particles. Okay, it is very tiny for both solid and liquid. Okay, solid and liquid, the particles are very, very close to each other. That's why both solid and liquid cannot be compressed. No compression can be done. 唔可以壓縮嘅。Okay, while air, it is possible because the particle of a gas that are far apart from each other can be compressed, which means that volume can be changed for gas. Can be changed for gas. However, it is impossible for solid and liquid to change their volume. Another part is about their movement. Okay, so first of all, a particle are moving all the time, all the time, but they are moving in different way. So, for example, for gas, they are allowed to move in any direction. Okay, because they have a lot of space, a lot of spacing, a lot of spacing. While for liquid, they are able to slide over each other. Okay, slide over each other. Remember, both liquid and gas, they do not have fixed shape. No fixed shape. Sorry, not, but no fixed shape. Okay. So for solid, although there has a fixed shape, yes, but still the particle are able to move, but in a very minor degree. They're only able to vibrate. Vibrate here means 震动. Okay, 震动. We can't see the vibration with our naked eye, but we can tell they are movement if we're trying to perform certain experiment. So far we have complete talking about the particle model of solid, liquid, and gas, and how do the particle they the arrangement of them, and also their movement as well. And we try to using these uh, we try to explain their features, their properties by using a particle model. Okay. After this slide, we're going to mention about how do we apply the particle model. Okay. So please look at this slide. Okay. So we have flour on the top and we have fried chicken. Okay. I'm very hungry right now. Okay. So first of all, when there's a flower at a distance, okay, so we can still smell it, okay, without seeing it. Why we can do so? Why we can know that there is flour or fried chicken without seeing it? What happened? How can you explain these using the particle model? So please think about it. So in fact, this situation is called as diffusion. Diffusion in Chinese called 擴散作用. So this diffusion is describing the movement of the particle. So from an area of high concentration to low concentration. Okay, if we're just now talking about the flour example, okay, this is flour. flower. So in fact, there is some particle that the flower even out. Okay, and this particle, as we've mentioned, they keep moving. They keep moving, and eventually it will try to spread all around, surround the surrounding. Okay, and these process. So these process, we have these processes are called as diffusion. From this high concentration, so more dots in this area, to lower concentration. Okay, so less dots. This is called diffusion. And diffusion not only happen in gas, but at the same time also in terms of liquid as well as solid. However, in terms of the rate, uh, in gas form will be faster rate. Liquid still okay, while solid is the slowest because the particle inside the liquid and gas they can move, so diffusion will perform faster in both liquid and gas. So consider this situation: if you add a red ink into the bottle of water, eventually, at the very beginning, this red dot would accumulate here, okay, and after some time, so eventually the red dot will spread over the whole solution. Okay, well, the color would be less intense comparing to this one. Okay, at the very beginning, this is more intense. Samsakti. Okay, because of this is high concentration, while here there's no red dots, so this is lower concentration. Eventually, they will spread, okay, until reaching this situation. So particle move randomly, so that's why eventually it will spread until throughout the whole container, the concentration of a substance are the same. Concentration here means 浓度. Okay. So right now we are going to apply the particle model. So I'm sure you've encountered this situation. So a ping pong ball, a tennis ping pong ball damage. Okay, so it can be repaired by putting it into the hot water. Okay, so why placing a tennis ping pong ball in the hot water can fix the ping pong ball? Okay, so for those who are interested, you may check this video. Okay, so what happened if we, okay, the first question, why it would repair? The second question, what happened if we, instead of using hot water, right now we use cold water, can the ping pong ball be repaired? Why or why not? What exactly happened inside? So in fact, if we're trying to put the ping pong ball into some heat source, okay, so when we hit it, so the gas inside the ball, in fact, it will expand. Expand here means 擴張 or 膨脹. Okay, 膨脹. So, which will eventually push the tin out and making the ball functional again. Okay, which means that if we increase the temperature, so the volume here would expand. Okay, they would expand, increase in the volume. Okay, so we can instead of using hot water, some I saw it from the internet. They use a hair dryer. They can also use hair dryer to repair the ping pong ball. Okay, but the reason right now is Why? Why when we heat up something, the volume of the substance will increase? Or we say, why if we increase the temperature, substance, they will take up more space. What was happening? Can these explain? How can this explain by the particle model? So in fact, this is called the thermal expansion or contraction. Okay. So first of all, when a substance is heated, okay, when substance is heated, okay, when we heat up the particle inside here, when you heat up, they will trying to move more vigorously. Okay, they move more vigorously. This is in solid. Okay, they move more vigorously. So eventually, so they will take up more space. Okay, so this was the original space. But however, after heating it up, okay, because all of them are vibrating more vigorously, 震動得更加激烈. That's why they need more space, more volume. This not only happening in terms of solid, but also happening in terms of liquid. Okay, so I wonder if you know what is this. This is thermometer. In fact, the theory behind why a thermometer can be used to measure the temperature is same. It's based on the thermal expansion. Okay, so when you heat up the particle inside, they vibrate, they move more quickly, move more vigorous. That's why they need more volume. They need more volume, and that's why it can be used for thermometer. So same situation for this one. If we heat up the bottle, the air inside would expand. So the particle, they move more vigorously. So particle move more vigorously. Sorry, vigorously. Okay. So if we consider solid, the particle in the solid will vibrate more when it is heated. That's why it takes up more space. How about liquid? When it is heated, it will move around each other more. Okay, in this situation, that's why it would take up more room as well. Okay, the last one for gas. When it's heated, it will move more quickly in all directions. That's why, again, take up more room. Students, you have to pay attention and remember when we heat up something, although it looks like larger, but the size of the particle itself does not expand. What is changing is just the spacing between particle. Okay, so if we heat up something, the spacing between particle increase. So vice versa, similarly, if we, instead of heating something, we cool down, okay? We cool down something. So obviously the spacing would then decrease. So in Chinese, we call this situation as 冷縮熱漲. Okay, so this is the only thing, only the space between the particle change. It's nothing due to the size of the particle. The size remain the same. So these are two application. Application here means 日常應用. So based on based on the thermal expansion. Okay. So we have just explained this, so we won't go through here right now. What I would like to put more focus will be this one. Okay, this is so-called the bimetallic strip. Bimetallic strip is very interesting because bimetallic from the term, you can see that bio here means two. Bio means two. Metallic means metal. So bimetallic strip is basically a strip containing two metal. In Chinese called 双 mean 金屬片. Okay, so just now we have mentioned a solid would expand when we hit it, when hitting. Okay. However, not all the metals, not all the substance, they expanded in the same degree. So metals expand in different degree. What does it mean? It means that, so let's say metal A, when you increase temperature, let's say you increase 10 degrees Celsius. Okay, so metal A may increase in the length, let's say 10%. However, another metal, metal B, it still increase, but they may increase in terms of, let's say, 15%. Okay, so there's difference. There's difference. So imagine what happened if we stick metal A and metal B together. So on top, sorry. So on top would be metal. Let's say on top is metal A. The one below is metal B. What happened if it is increased 10 degrees Celsius? So remember, B expand more. So you would expect that if we increase the temperature, this metal strip eventually would bend. So it would bend upward. Sorry for my poor drawing skills. Because B expand more. Expand more. So you can go home and check this video. You're going to see more about the bimetallic strip. Usually this is used in some device that is depends on the change on the temperature. For example, some heater. Okay. So next part, we're going to talk about the density. Okay. I'm sure some of you have already encountered this word, density. Density means 密度. So by looking the following, which of the diagram you think that it has the greatest density? So the word density has the meaning of how close are the sorry, how close are the substance packed together. Okay, so if I just look at the density here, probably I would guess this is the most dense because I found that this area should be more filled with the black dots than this one. Okay. How about when we're going to think about solid, liquid, and gas? Which one has the highest density? Which one has the lowest density? So as we've mentioned, we're talking about how close are the substance packed together. If we're talking about close, basically we are talking about the spacing. So because solid has almost no spacing, okay, while liquid had a very, very little bit spacing between particle, gas had a lot of spacing. So obviously, solid has a highest density, highest density, while the gas has the lowest density. Okay, consider the following slide. So density of the matters. Yes, we just talked about how tightly packed the matter is. Okay, we're talking about the given mass in a given space. So mass here means subtler. Okay, so obviously gas is less dense while solid is more dense, while liquid somehow in between. So density can be easily calculated by using this formula. Density would be equal to the mass divided by volume. Okay. On the internet, I found this interesting triangle or triangle of power. Okay. So this is a way for you to memorize how do you calculate density. So density here is equal to the mass divided by volume. Or the other way of thinking of that, volume here is equal to the mass divided by the density, or mass is equal to density times volume. Okay, it's just a way of thinking that if you could memorize this, it would be good enough. For example, let's say water. Okay, if we want to find the mass of density of the water, first of all, we need a cup of water. Okay, we need the water. And then we're going to find the mass of the water only. Let's say this water is 10 gram, sorry, 100 gram, 100 gram. And we need to find a volume. So the volume, let's say is 100 cm cube, okay, volume. And then we're going to find the density. Density, so it would be the mass, 100 gram divided by 100 cm cube. The unit, pay attention, the unit of the density is gram per cm cube. Okay, so this is the density of the water. So density can also help you to find out whether if the object is floating or sink. For example, water. If so, the density of water is 1 gram per cm cube. Okay, 1 gram per cm cube. So if I have an unknown solid, let's say solid A, the density is 2 gram per cm cube. Okay, so because solid A has a higher density than water, so solid A is denser than water, more dense than water. So you could expect that if I place solid A into the water, solid A would sink to the bottom. Okay. Temperature can affect the density. Okay. So let's take these example. Hot balloon. Okay. So why temperature can change the density? Okay, let's take this diagram example. We have a heat source here, and the heat source is keep heating the air within this balloon. So this particle, the red particle, is heat up. That's why they move more quickly, more faster. Okay, and then when they move faster, they are more far apart from each other, Okay, and that's why they take up more volume. So eventually, of course, the density decrease. As we've mentioned in last slide, When the density decrease, it will flow. Okay, that's why the hot balloon can rise. So this graph here, this graph here is showing the summary of what I've just said. Okay, but right now they're just using water as example, but they're the same. So first of all, water, the warm water particle have more energy. That's why they move faster. They move faster. And when they move faster, they move more far apart from each other. When they move more far apart each other, which means that in the same volume, same area, okay, there will be less particle. So that's why warm water is less dense. Okay, similar situation for warm air. Okay, you just replace the water into air as well. So in the other way around, the cold water have less energy. The cold water which makes the the particle move slower, and that's why they tend to stick together. So that's why more particle in the same volume. That's why cold water is denser, is more dense. Okay, so this is a situation of hot balloon. Why hot balloon can rise. So this is another interesting situation. Okay, instead of talking about density, so I wonder, have you ever heard about a place called Dead Sea? So Dead Sea is a sea that are full or has a high amount of salt, So this phrase, you can't drown in the Dead Sea. The reason very simple, because it is very hard for you to immerse, to sink in the Dead Sea. Look at this gentleman. Okay, okay, he is reading on the water. So why he can float? So why this gentleman float? Why this gentleman float? If we're just using the concept of density, when something flow, which means that it has less, it is less dense. Okay, so it is in this case it's less dense than uh, the sea water in the Dead Sea. Okay, so what makes the sea water in the Dead Sea so dense, denser than normal seawater? The reason because in the Dead Sea there's a lot of salt, high amount of salt, and these salts would dissolve into the water and causing more particle in the same volume of Dead Sea. So instead of normal fresh water, right now within the same region with a lot of salt. So that's why the salt water is more dense than normal water. Okay, so this situation can be also applied when you're comparing the fresh water and salt water. While in the Dead Sea, it's just more exaggerated, more salt in the same amount of water. Okay, so that's it for the density part, and that's it for the particle model. So in case if you have any question, please feel free to email your question to your science teacher. Okay, that's it, and thank you.